Yeah, so over all these years now, we've gone from liking preservative-free, clean label to getting rid of plastic to now climate change, and we're all seeing how serious the climate situation is. And obviously, for example, I'm using old numbers, but back in 2012, about 150 million pounds of fresh salmon was being air freighted in the United States every year. I think Costco was buying about 25 million pounds of that back then. And it's all being air freighted in. I don't have the numbers in front of me, but this technology can bring that same product to the same marketplace at about 1/100th of the carbon footprint that air freight delivered product.
Hi there, food enthusiasts. My name is Chris Strechkowski, your host again today for the Future Foodcast, where we talk with thought leaders in today's food industry and discuss the trends and technologies that will shape the future of food. Very, very happy to be speaking with Larry Bell today. He is the inventor and developer of the Sustainably Fresh Systems product, which is, we're going to learn much more about this later, essentially a very novel but actually highly proven process for shipping containerized food products and maintaining their freshness. And I'm going to let Larry get into that a bit later. But first, welcome to the program, Larry.
Thank you very much. I appreciate your interest.
Yeah, of course, of course. I've had the good opportunity to talk with you a few times previously, so I've learned a lot about this, and I'm excited for people to learn about it. But first, let's go back a little bit and learn a little bit about your history, because this isn't just some new idea for you. You're an expert in the sustainable food management space for decades. And tell us a little bit about your background before you started with this particular product of the Sustainably Fresh Systems.
Sure. I don't like talking about myself, but briefly, my degrees are from UC Davis, BA in biological sciences, BS in microbiology, and I fell into a master's, MS, in food science and technology. A professor approached me and gave me a C grant, if you will, in the food science department to complete a master's degree. So I got paid to get a degree in food science, which led to a very exciting career, and I'm still involved in it, and it's remains exciting. So while I was doing my graduate work, I had the opportunity to see some research being conducted by a company called Transfresh Corporation, which was initially a joint venture between Whirlpool Corporation and a lettuce grower in Salinas. Basically, what I was seeing for the first time, it wasn't even taught in the food science curriculum at UC Davis back then, was what modified and controlled atmospheres can do for fresh foods, meaning mixtures of carbon dioxide, oxygen, and nitrogen surrounding a fresh food product that extends its freshness beyond what would otherwise be possible. And that particular technology is if you will, a clean label technology. It's preservative-free technology. FDA does not require labeling that you've adjusted the oxygen or carbon dioxide around a food product, except for fresh fish. Back to the graduate work. So when I saw the amazing results in this lab where I was doing my graduate work, to make a long story short, I ended up working for that company, Transfresh Corporation, site years. But back in 1978, my first job with them was to go to Alaska and figure out how to ship fresh salmon by refrigerated container from Anchorage to Seattle, which heretofore had always been air freighted. Or what they couldn't air freight, they would stuff into cans or into freezers. But that particular year in 77, a guy called up on the beach in Kenai Peninsula and said, I'm stacking up fresh salmon on my lawn. I hear you guys have modified atmospheres that might be able to keep my fish fresh long enough because the canneries are full, the freezers are full, et cetera. So they made a quick test in 77. It looked very promising. They hired me and said, Larry, make it happen in 78. So that's where the saga began, way back then. And
that's an amazing background. That's not even all of it. Not even all of it. So I'm going to get you to reveal more about kind of your experience in the space, because it's very important that people really understand that technology is novel in many ways in what you're doing today. The core science goes back, like you said, to the 70s. And just so people understand, we're talking about putting food products in a controlled atmosphere. In other words, not normal air, but it could be nitrogen, in a low oxygen atmosphere. And that extends, if you will, extends the shelf life of that. And you really built on that, as I recall, through a number of different companies and many different products over the years. And if you could maybe just tell us a little bit more about these areas you've worked with, because some people like myself, we bought these products out of supermarkets in the US and didn't realize the key person behind keeping our salad fresh, for example.
Yeah, well, who cares, right? Just make sure it tastes good and the price is right. But yeah, so briefly, back to Whirlpool Corporation, because when you say you're alluding to how the history of the technology, Whirlpool was involved in the corporation because they made appliances. And one of the appliances they made was what's called a catalytic generator, which they use in Apple cold storages. So apples have been put into controlled atmosphere storage back almost 100 years. So Whirlpool was selling those appliances to Apple, people storing their apples in controlled atmosphere to create that atmosphere. So the technology is very old, but what's much newer is the application of it in packaging, in containers, in pallets, etc. Like I said, my priority when I came out of graduate school was I wanted to work in preservative-free, clean label foods. And way back then, fresh salmon was obviously one of those. And I just, by serendipity, ended up, immersed in this technology that really hadn't been fully leveraged, if you will, across the food industry back then. And I ended up in a good place to try and expand the leverage of it, because I did work for that lettuce company that today is known as Fresh Express. And my boss, after I came back from Alaska, because that was a summer gig, my boss said, well, the next thing I want is salads in a bag ready to eat. So we built a team around that, and I was fortunate enough to lead that team. And we came up with a lot of novel tools, if you will, measuring the respiration rate of cut salads. How fast does it breathe? How much oxygen does it consume? How much carbon dioxide does it give off? All that kind of stuff. But it took a little while, but eventually we came up with the key, if you will, the technological key to managing that environment around cut lettuce, such that it would last long enough to be distributed nationally. Anyway, Fresh Express became a new brand, and ultimately, without virtually no, if you will, promotion, was one of the fastest growing new brands in history, because when we put packaged salads on the shelf, people just swept them off the shelf. And anybody who's old enough to have before that category ever emerged, see it grow like it has, it's a multi-billion dollar industry now. I've got a patent from way back in, but everybody, at the end of the day, our competitors like Dole were able to reverse engineer what we did, because once we figured out the best plastic and it had the right technical properties for preserving shelf life, printability, and the right machinability, our competitors would just go to the shelf, buy our product, and take it to their suppliers and say, copy this. So the industry grew fast, and it was a great ride. I had a great team helping me develop it. And all along the way, we kept going back to our summer job, which was let's figure out how to make the salmon thing work. And
okay. Well, and I think that this is an important point, because a lot of us go to the food store and buy our packaged salad and really don't think much about it other than it's nice to have it there. But we are, I think, very happy to have you on this program as sort of the father of the technology behind packaged salad. So that's great to have, a good part of our sustainable food chain. But tell us more about what you're working on now, both what the product is, and then we'll talk about how that's going to further revolutionize the food supply chain. Maybe you can take us down the development and the technology and product path from how you moved from packaged salads into what you're doing today.
So the work up in Alaska went very, very well for that first year we did it. But we had about 10% of the salmon arriving in Seattle with a brown discoloration where the head cuts were, or where the belly flaps were. And I knew from the work I had done in graduate school for a Sea Grant, and I won't go into the details of it, but I learned during that period of time that eliminating oxygen, and I mean eliminating it, was critical at certain points in a process to prevent that browning problem. So I knew I had to get oxygen out of these containers, but there was no way to do that back then. And so the real journey was, how can we get oxygen out of this container? How can we remove it? How can we suck it up? How can we absorb it? What can we do? Everything we tried, nothing worked. And one day I read in Business Week, I think it was, about a company that produce the equipment that extracts oxygen from seawater on nuclear submarines. And so I contacted that company and said, if you can extract oxygen from seawater, you can extract oxygen from a container full of CO2 and salmon. And they said, yeah, we probably can. So we ventured together with that company. It was called Giener. They're still operating today. They're an electrochemical, really high-tech electrochemical type company. We built a system that was very, very complex and expensive and power hungry, but it worked. It was an electrochemical system. So the guts of it are a fuel cell type of technology. The way they built it, it was just too many bells and whistles and failure points, et cetera, but it worked. We actually shipped salmon, I think it was in the 80s, late 80s, from Chile to the United States for over 30 days, and it arrived amazingly fresh. So we knew we had something really interesting and valuable. And now the planet's beginning to suffer from climate change, and sustainability is really important. And what I had forgotten to mention before, packaged salads were great for the consumer, a convenience product, but they really are bad for plastic pollution. So this technology, for proteins anyway, can get rid of plastic packaging. So now with this technology, you can go in paper. You can take the hundreds of millions of pounds of fish that are flown from around the world into the United States every year that can't be vacuum packaged. That's the only fresh food product that FDA doesn't allow to be vacuum packaged. So we wanted to provide an ocean transport, that option, once again, back to Alaska. And so everything was moving more from Alaska to the global opportunity in front of us. I got together with an old friend back at Fresh Express, and we decided to start a new company and see if we could make this technology work using electrochemistry. So the end of the story is we started a company called Global Fresh Foods in 2006, and we built fuel cells, very simple single fuel cells that go inside a 1-ton package, which is a sealed pallet with 2,000 pounds of salmon fillets in it. And our fuel cell system sits on top with unpressurized hydrogen. The fuel cell consumes the oxygen, turns it into water vapor. And in that high CO2 environment, and between the high CO2, which stops microbial spoilage and with proper refrigeration, and the ultra low oxygen to nearly zero oxygen, which stops oxidative deterioration, rancidity, discoloration, the browning problem I talked about. That's where we are today now. With the Blue Wrap technology, we were able to create that environment, demonstrate to the world these amazing extensions of shelf life. I was all over the world back then, Chile, Norway, Vietnam, Japan, watching people get blown away by how long we could keep really fresh, microbiologically fresh, everything about it. Like the day it was cut, people would say, this is amazing. The problem was Blue Wrap's service. The palletized version that we created turned out to really be too expensive to operate and didn't offer enough economic incentive to users to change their fresh food supply chain.
Well, I just want to kind of bring our audience back to a point that you had mentioned to me before, which I think really helps, I would say, the average person understand the real capability of this system, where you are essentially able to containerize fresh fish in a controlled atmosphere, like you said, high, mostly CO2 and very, very low oxygen. And it can be delivered 30 days later, still being fresh. And what struck me in an earlier conversation is, I think this was in Japan, where you were working with salmon delivered to sushi chefs. And of course, who might be better experts in judging the fresh quality of a fish than a person like that? And tell us a little bit about that story, because for me, that really struck home the reality and value of potential of this technology in your products.
Sure. So that was back in 2012. I was the CEO of the company then. I wanted to really put the fresh salmon technology to the acid test, which, as you already alluded to, Japan is the acid test for fresh fish. So for the first time in history, we put a couple tons, 2 pallet systems in a container, and for the first time in history, shipped fresh Chilean salmon, farm salmon fillets to Tokyo, Japan by ocean. It took 40 days for the product to get there, and we opened it. It was diamonds. So then the Japanese company that I was working with said, let's take it to the sashimi people, the experts in making raw salmon into a food product to be eaten raw. So we went there, and their normal supply chain is air freighted Norwegian salmon, headed and gutted, which they then have to fillet and blah, blah, blah. And then they make their sashimi. Ours comes in as a fillet fresh. And so they don't have that extra step plus the air freight cost, et cetera, et cetera. So anyway, it was day 42 when we went to that plant where they did their treatment of what they don't rinse it and they don't add any preservatives. It's sashimi, meaning you eat it raw. Me and one other guy that my guy I was working with at the time, and the rest were all Japanese, and we're eating this 6-day Norwegian-based fresh salmon sashimi next to our 42-day fresh Chilean-based manufactured sashimi product. And in our slide deck, you can see I show the Japanese gentleman just loving the 42-day fresh fish, and that was the ultimate acid test. So they couldn't tell the difference. And on top of that, the Japanese have a microbiological criterion, which if you exceed, you cannot sell it as fresh in Japan. So this 42-day fresh salmon passed the Japanese microbiological criterion too. So it's an amazing technology, but it was not priced right in our first venture.
Right. So that, like you said, that is, I think for all of us, we can see, as you said, the acid test or the harshest test for the proof of the capability of this technology and the product. So maybe now tell us more about how you're changing the economics and moving from what had been a palletized system, which was too expensive, into a containerized system that is going to enable the transport of fresh fish globally via ocean, and at a huge cost reduction, huge reduction in savings, like you said, in plastics, and also, of course, fuel to transport without using, airplanes to fly fresh fish around the world.
Yeah, so over all these years now, we've gone from liking preservative-free, clean label to getting rid of plastic to now climate change. And we're all seeing how serious the climate situation is. And obviously, for example, I'm using old numbers. I haven't updated them recently. This has been rolling very quickly in the last couple of months. But back in 2012, about 150 million pounds of fresh salmon was being air freighted in the United States every year. I think Costco was buying about 25 million pounds of that back then. And it's all being air freighted in. I don't have the numbers in front of me, but this technology can bring that same product to the same marketplace at about 1/100th of the carbon footprint that air freight delivered product. So obviously that's very important for climate change because there's a lot more fish being flown around everywhere. And the reason fish is flown, unlike beef, which is vacuum packaged, fresh seafood is the only, if you will, category of fresh protein foods, muscle foods, whatever you like to call them, that the FDA in the United States is not allowed to be vacuum packaged. If you could vacuum package this fish, a lot of it, could just be moved around by ocean like beef is. But because you cannot legally package seafood in a vacuum, it has to be transported in a highly regulated manner, meaning you have to know your cold chain at every point along the way and be able to prove that to the FDA on arrival, which I know you guys are involved in some blockchain issues and technology.
Yeah. And of course, no matter how good your refrigeration is, it doesn't work for 40 days.
No, it does. Ocean, that's the beauty of Ocean. So I am not recommending this technology for over-the-road refrigerated trucks. They're not constructed adequately for this technology. Ocean containers are the most reliable refrigeration systems in the world.
But you need the controlled atmosphere with it, I guess is what I mean. Without controlled atmosphere, this doesn't work. Correct.
Absolutely not. Yeah. The only place it might work is if you're within a week of your destination by ocean. The shelf life clock, if you will, keeps ticking without this technology. So if anything gets delayed or goes wrong, customers may not be very happy with the fish that isn't really as fresh as they, whereas this technology literally stops with the proper refrigeration. Microbiological spoilage, they just don't grow over these 30 to 40 day periods. And the ultra low oxygen stops the oxidation issues. So with all this compelling climate change benefit, really that has to be number one on the list for these folks around the world dealing with fresh muscle foods. They've got to see substantial profitability from using this technology. So unfortunately, the Blue Wrap technology, when I was involved, and I have not been involved in managing that company since 2012, but obviously
that was a smaller palletized version.
Yeah, and you have to take it to a cold storage. So the fish producer must first pack the fish out, and then it has to be shipped to a Blue Wrap cold storage facility where they put it in another palletized system and construct a system and gas flush it and do all this stuff. And then you want to ship full containers, right, to minimize freight costs. So you got to produce 18 of these 1-ton pallet bag systems in a special cold room environment. So the salmon packer ships it fresh to the blue wrap place. The blue wrap does their thing, and then they ship it, put it in a container, and away it goes. And that all takes time and money. With this system, it pulls up to your loading dock, Mr. Fish, frozen fish producer, pulls up to your loading dock just like your frozen fish container would, only you're going to put fresh fish in this container. And you can do that because it has the technology that we've invented here and are now commercializing in that container. And at a cost that is, again, I haven't been party to the exact cost of blue wrap today, but at a cost that is probably 1/10 the variable cost of a blue wrap system. To break it down into dollars, let's just say you're paying 75 cents a pound today to get your fresh salmon by air to Costco in LA, 75 cents a pound. This technology will get your fresh fish anywhere in the world for half of that, if not. So now you're talking about, 50 cents a pound maybe, or which, when you're shipping millions and millions of pounds, it's a lot of money. And so then you can flow to superior freshness, you can flow to superior shelf life and climate friendly technology. So
exactly. And also, of course, when it arrives, I think you have the flexibility of, it can stay in the container for a day or a week, as long as you're inside that 40-day window. And in other words, it makes the logistics easier for dealing with the product once it gets to its destination. So that flexibility is tremendously valuable in the food chain, in the supply chain.
Yeah, and you made a very important point, is shelf life after arrival is critical. And this technology delivers 90% of the shelf life that product would have had from day one on arrival after it's removed, after you may even inventory it for another 10 days or 2 weeks. So my point is that vacuum package meats, a vacuum package does not have ultra high CO2 in it. It only has ultra low oxygen. And so when you open a vacuum package of meat, it's going to have maybe 25% of its fresh shelf life left once that vacuum package is open, whereas our system produces 90% of the original shelf life. So that's a big deal when you're trying to change your supply chain. You've got to have enough shelf life at the marketplace, to be as good or better than what you have been doing.
So it sounds like, and what we've described here is really your product is certainly applicable on a global basis, is amenable to global ship transportation, even the longest routes, Southeast Asia to Seattle, probably one of the longer routes in the world, and tremendous cost savings to go along with that. And you touched also upon some of the packaging cost savings and the pollution related to that. And, I think a lot of people might not realize when traditionally, or let's say the standard process for transporting fish today, there's a tremendous amount of plastics involved with that, both the packaging directly around the fish probably, but also styrofoam, et cetera, for keeping it cool. Yes. Maybe explain to us a little bit about how all that can go away with your system.
Well, one of the important steps in ensuring that this technology does what it's supposed to do is chilling the raw product before it's packed. So because our system is constantly refrigerated, we don't need to have ice in the package. You literally just can put a 50 or 100 pound box of fillets in cardboard instead of styrofoam, because it's going into a refrigerated container, not sitting on a tarmac at an airport, right? So now you're not packing styrofoam, you're packing corrugated cardboard boxes with your fillets. No ice is necessary, but you must pre-chill those fillets, which in Chile, all their plants pre-chill for air freight to help them get there. And once that's it. You don't need any plastic, you don't need any ice, you don't need any styrofoam. So, there's tremendous savings and reduction in pollution of by styrofoam. Slide in the deck I'm using showing a mountain of styrofoam in Tokyo, literally a mountain with bulldozers trying to get rid of it, move it someplace from air freighted fish.
Yeah. Well, everything that you've developed over this time and everything that's going into your product, literally all of it is aimed at sustainability. And part of sustainability is, automatically, and if done well, leads to cost reduction. So it seems like the entire foundation of your technology really aims at a much more sustainable food supply system across the full spectrum of energy use, carbon footprint reduction, waste reduction in plastics, and we're improving the logistics situation by making it more flexible and more efficient for both the supplier side and the delivery side, and for the, if you will, the last mile logistics.
Very well summarized. And also I would add a reduction in food waste, because with our extremely fresh arrivals at the marketplace, there will be less spoilage loss. And that's another big deal today in the world. In fact, here in California, they're making us, what do you call it, to put all your organic waste. And so the other area that, very briefly, that I believe we will be able to improve is the vacuum packaged meats. I mean, off the top of my head, I can't tell you how many millions or billions of pounds of beef and pork, et cetera, are moved around the world in plastic vacuum packages. We'd like to convert that, take away the capital investment in the equipment and the cost of all that plastic in the process, and instead see meat shipped without plastic in our system. Remains to be seen if we have the price point for that, but I believe we do.
Right. Well, and it's probably also, good to point out that key area that you're starting with on the technology is probably one of the higher value ends, which is an easy place for new technologies to start, is high value consumer needs. And fresh fish is certainly one of the higher value products there. But as you're describing, as the containers become much more ubiquitous, the costs go down with every new container that comes into the market. And that cost probably can also be extrapolated across producing or shipping other types of fresh meat products and proteins. Is that what you're saying?
Yeah, it's and the other area, we mentioned Tokyo. This technology could also be manufactured into vending machines. If you've been to Tokyo, you want to get your sushi out of the vending machine. With this technology, you can equip the vending machine to keep that sushi as fresh as day one for 2 weeks. You don't have to reservice that vending machine and sell your fresh sushi. So. That
would be pretty amazing. For anybody that's had who doesn't live in Japan, but who's had the good opportunity to go there, it's an amazing place to be with the technologies that exist in terms of convenience in shopping. The vending systems in personal vending machines in Japan are pretty special, and this would be a great addition to that.
And I'd like to see the technology be incorporated into cold storages where they would have a fresh inventory room. Because we're also talking about converting frozen supply chains to fresh, because to be honest with you, it costs way more to freeze a piece of fish. Right. And usually it's sold at a lower premium than fresh. Ship it fresh. So and that's another climate change opportunity. Is freezing is a very energy intensive process.
Well, it sounds like as we start off 2022 here, we have a lot of good things to anticipate with your products here, and bringing more or better sustainability initially to the fish supply chain, global supply chain, but extending that across other proteins and who knows, maybe other products. You've already proven the capability decades ago in the salad area. As the cost goes down, there may be even more applications across all different types of food products, and extending the shelf life by essentially keeping it zero shelf life until it gets to a food store where it can be, wait for a final consumer like me to purchase.
Today, the technology is heavily used. I mean, virtually every food product you buy off the market, off the shelf in a grocery store, probably has a modified atmosphere adjustment to the internal atmosphere of either increasing CO2 or lowering oxygen.
I think this is my first podcast of the year for Future Foodcast, and I think it's very appropriate that it is with you and your products for Sustainably Fresh Systems, where I think we can have very good expectations of, for example, enjoying our salmon that's sent from Chile, arriving fresh and not frozen. Yeah. Chile, Norway, prawns from Southeast Asia, all sorts of different products that this is going to be, this is applicable for. And really have to thank you and the people that you've been working with for bringing this technology to market. It's not easy to do. And as we see, it's taken decades to get here, and it's time that it finally becomes the low-cost containerized version of controlled atmosphere for shipping initially fresh fish products.
You bet. I couldn't have said it better myself. I certainly appreciate your interest, and we're very excited to see this technology commercialized to the benefit of virtually everybody.
Excellent. Well, thank you very much for being on the program today, Larry. And we look forward to having you back again and learning more about, as you're making progress with this product, how it's progressing and how it's bringing more sustainability to the food supply chain.
You bet. Thank you very much.
Thank you.
Thanks for listening to Future Foodcast. Future Foodcast is powered by Farm to Plate, the leading food blockchain platform. Subscribe on YouTube or wherever you listen to podcasts to stay up to date with the very latest innovations in the food industry.